How you doing? Okay, so this lab is a really cool lab where we're trying to find out the molar mass of the gas that will come out of this little gizmo right here. So this is a little lighter. The top has been taken off. I've taken part of it. The gas will escape. So here's the plan. Step number one, you want to get the mass of this nice and dry. Next thing that I do is you can see I've got water here. So I've got a 100 mil grad cylinder. It is filled with water to the very top. And the goal is to bubble this into here so the gas goes up and the water goes out. Now, one thing that's helpful, I may not use it now, but if you put this on the bottom of the cylinder as the gas goes in, it's easier to get it in. I'm going to try it without it. You decide. We'll get it going here and you get to see how that gas goes in. So we've got the mask. Now, while we're doing this, so you can start seeing that the bubbles are going up right here. So I'm going to do this until we get to about 85 to 90 milliliters. A couple of things we'll need to record also. We want the temperature of the water. The temperature of the water, as it turns out, will also help us figure out the temperature of the gas inside here. So if we know the temperature of the water, we know the temperature of the gas, and that's going to turn out to be kind of important. The other thing that we'll need to figure out is the barometric pressure. Okay, so it's assumed the pressure outside of this graduated cylinder is the same as inside. Hey, here's the good news. Turns out, for some unknown reason, most of the newer iPhones now have a barometric pressure sensor built into them for some reason, and they are extremely accurate, so we can figure that out. So we have the temperature of the gas, we have a pressure of the gas, we might need to know something called vapor pressure. We've got the mass of the gas and the container before. I'm not going to let this go the whole time, but I'd want this to go down to about 90 milliliters. I'm going to stop it here. So if I were to stop here, then we can carefully dry this off as best as possible and get the mass after. And those two should be different. That's the mass of the gas in here. So why are we doing this? Well, because is it possible to find through gas laws the molar mass of any gas? And the answer is yes, and it's pretty cool, and it works amazingly well. So this is the setup. Now, one last thing. When you read this, to get a really good reading, what I'll do is this will probably be down all the way to here. I want the level of the water here and the level of the water in the tube or in the tub here to be about the same. That will give me the volume of gas. I could just read it off here in milliliters, and we find that that works really, really well. So the goal, can you take enough data and do something with that data to figure out the grams in every 1 mole of a particular gas, specifically the gas in here? Okay, good luck. And if you have any questions, don't be afraid to ask. If I can turn this off, maybe.